someone in my lab really recently. But this is how any for loop is set up. And so what we could do is, so not our goal, but just to show what a for loop can do for something. And you can call this something anything you want. It's pretty common to see people use I to stand for iteration or iter. So like in iter 1, iter 2, iter 3. So for I, and we're going to list our penguin species. And I'm going to look at my notes because I don't remember what they are. Oh, comma. Maybe I should copy paste. So for our 3 species, curly brackets, we're just going to tell it to print. So just print the species names. You can be anywhere in this for loop, so I don't have to be on the first line to run it. I can be in print and hit, oh, no, you can't. Fun. Okay. That's not a trick that works anymore. So you have to be on the first line. Take back what I said. To run a for loop, put your cursor on the first line and hit run. And we see that it does just that. It replaces I with Adelie, and then with Chinstrap, and then with Gentoo, and does the thing you tell it. And just to show you that I really do mean you can name it anything. So I'm just going to copy this. This can be, my favorite thing to use is magic, because coding is magic. That this word can be anything, as long as it's the same thing that then you use inside of the, the curly brackets. So run does the same thing, prints the 3 things.
Hey, Kim, we have a question.
Yeah.
The question
totally ran and
is,
lost my chat video.
It's okay, I can read out the question for you. So the question is, do you have to type out all of the categories in the species, or is there a way to do all levels, factors, or categories?
It's like you read my mind. That's the next thing, that's the first part of automation. That's not even really automation. It's just, I don't want to type out these 3 things. What if I didn't know what they were? What if I add a 4th species? What if I get new data? So that's exactly what we're going to do. I'm going to copy this. Actually, I'm going to copy the I one because magic is a bit of a weird way to do it. So make R figure out these species for you. So paste that. And instead of doing this, what we're going to do is go into our, our DAT. It could be DAT or DAT filter because, we're in the end going to loop it, but we're just going to do DAT so we can see all 3 right now and say the species. And so this is not the full thing, but I'm going to show you, this is one way to access, everything unique or everything that's there, but it's not unique. So if I run this, right, it's going to print out 1 for every single line, every single row. So what you can do is if you're not sure if you have what's the word, a factor. So there are a certain type of data in R that's a factor, that's things like this where it's words or numbers and you tell it that there's specific levels. And so for a factor you can use levels, but I'm not sure if species is a factor and I don't want to check. So what I can do is instead do unique. So if I actually just run this line of code, you see it lists the 3 and it actually is a factor because it's telling me levels. So I can show you both. So this will do the 3 for me. And if it's a factor, you can do levels. Does the same thing. Lost my notes behind the chat box. Got them. So that's how a loop works. You can put anything here. You can put a list that's 1,000 things long. You can have hundreds of lines of code in between the curly brackets doing things. My most atrocious, but it works and it's not that slow, is I have one that has, I think, 3,000 lines of code to make customized plots with up to like 10 panels. It's ridiculous. I don't know why I made it into one loop, but there it is. It took a long time. So we're only printing something, but we could do all of these steps, which is what we're gonna do. So loop to make plots. So the same exact sort of setup is for I, just to keep it short, in our unique dat species, curly brackets, we're going to go up to our code here, and we're going to copy steps 1, 2, and 3. And we're going to stick it inside the curly brackets. Yes, it just fits on one screen. So in order to make it actually loop, we have to use I. So we need to just replace anywhere we have the species with I. And I love doing this with titles because now it's going to automatically put the titles. So if I run this, let me clear out my plots just so you can see that they are new. So if you run this, we see that it is made 6 plots. Now, if you look at the notes, I also have a step that we're not going to do because we don't have to, but it's just to make the notes look pretty, but I'll put it in here as like a reference. So if you don't want to scroll through a bunch of plots all at once, you can make basically a grid to put them in. So par, I'm a row, and I want 3 rows for the 3 species and 2 columns for the 2 different measurements that we're plotting. So if I do that, now, this looks great in your Markdown, or it looks horrible inside of my tiny little window. But we're going to comment that because we're not going to do it. But if you look at the notes, that's a bit of a difference specifically to make it look better in the notes. So that's basically the intro to loops. And this is a good way to build them, is to build what you want to do on one level first, on one species in this case, make sure it works and does what you want, and then put it inside of a loop to have it run. Often, if this is really, really long, maybe run it on the first 10 to make sure it's doing what you want without, waiting an hour, and then run it on everything. We just have 3, so we can test it just on the full data set. So that's all I'm going to do on regular loops. So before we transition to another way to do automation, are there any loop specific questions or things I can add to the notes if you don't see them? Okay, so that's loops. So we're going to do a bit of a bait and switch in that the first thing we're going to do is we're going to take the code inside of the loop and make it more efficient. So we're not repeating for each species because we're looping, but we are repeating our change in the measurement and our plot. So we're going to use some other automation techniques to make this code more efficient and shorter inside of the loop. And then in the end, get rid of the loop and do it without using a loop at all. So one way to do a repeated task, particularly if it's a simple, easy one, is apply functions. And I will admit that apply functions are often preferred over for loops because they are much faster. They rely on things like matrix multiplication, which is like wicked fast in R. So if you can get away with doing it with an apply function instead of a for loop, that will be faster. But I have to confess, I use more for loops because that's what I learned first. And I find them easier simply because I learned them first. And this workshop was a great motivation to make me go look at some of my code and say, okay, this should really be an apply function. So the way apply functions work, we're just going to use or not base R, but like first type of apply, which is just apply. There are other types like L apply, S apply for different kinds of data. Since we're just working with a data frame, we don't need to use those. We just use the normal one. And we can say, apply something across all rows. And we do that with margin. And this isn't the code, this is just a note. So you can do margin equals 1 for rows or across all columns is the other margin. Ooh. Equals 2. And so I think about this the same way I think about that a data frame is dat, rows first, columns second. So that's how I remember that, is that this is, 1, and then this is 2. And that's how. Or if you forget, as I sometimes do as well, the help function. Whoa, don't give me the function. Bad. So question mark, any function in here. Nice reminder of what the margins do. So we want to convert millimeters to centimeters. So let's do that. So we're going to have our DAT. Since we're going to be in the loop at this stage, we're going to be working with DAT filter. At this example, even though it's not inside the loop yet, we're also going to work with DAT filter just so that it will easily paste into our loop when we do that. So we're going to call it centimeter version now and apply. DAT filter. The data we're going to do across columns because that's where our different millimeter measurements are. And the way you tell it what to do, this is why I like these really for simple functions, is because you quite literally write a function. You say function of, and in the similar way that the iter, the I can be anything, what you function on can also be anything. But to keep it simple, if you're only doing one thing, you can use X, but you could have X, Y, Z, you could have words, you could have a data frame, craziness. But function of X, we're going to do X divided by 10. So what it's saying is for the columns of that filter, take the value as represented by X, never put anything there, and divide it by 10 and replace it. But we see when we try to run this, we get an error because the helpful but not helpful thing about apply functions is that if we go to like that filter, it's trying to apply this to every single column. So when you have a data frame or some other kind of data where you want to do something to all of it, all columns independently or all rows, then the apply functions are, right out of the bag, great. But we have to do a bit of changing because this is trying to divide, words by 10, which doesn't work. All columns. So that's just there for reference. I'm going to copy it and we're going to fix it. So instead, we need to tell it a subset of columns. And there are quite a few different ways to do this. I find the easiest is to just modify, again, with those square brackets of what columns do I want. And if you want to live dangerously, you can tell it just the column numbers. So like I know that my columns of interest are, the third and the fourth column. Oh, come on, show the thing. Third and fourth column. So I call this living dangerously because if your data change at all and your columns move at all, then everything breaks. But it is the shortest way that I can say, okay, do this, but only do it on the 2 columns that I want you to. And so we can see here, a new thing has appeared, and we see it's the 2 columns with the old column name. So these are now centimeter measurements, but they kept the old column name. Just something to be wary of. A slightly better way, but more code, or not more words, is instead of saying 3, 4, because I figured out where they were, is I want to just give the variable name. And if I say this is longer, but I personally prefer it because data are always changing. Depth. So now it's going to do exactly the same thing, but on the columns I gave by name. So you can see, it makes the exact same thing. So we can either use the indexes or column names. So you may be thinking, as I was making this, well, this is technically 1 line of code. Like I said, I split things across many lines to make them look nicer, but this is technically 1 line of code versus 2 lines of code. So have we gained that much? No. But in this case, there's two huge great things about this, is that the first is that if I want to add more variables, then I just have to add them to this vector here. I don't have to copy paste a whole nother line of code. And so if I had 30 variables, this would be a lot fewer lines instead of just one fewer. And the other part is that apply is way fast. That if this calculation were something other than simple arithmetic, or even if it was a lot of simple arithmetic, apply can be up to like 100 times faster than doing each line, because of things like matrix multiplication under the hood and how it's, and C++ coding under the hood, which I don't look at. C++, I do not know, but I know it's faster. So I'm not going to paste this into the loop, but you can see that we would replace this line with our one new line that is slightly shorter, and if we were doing something big, would be a lot faster. And all the apply functions, this is the function where you can do really complicated things if you want. I've seen people put plotting functions in here, modeling functions, like linear mixed effects model functions that they apply to every variable in the data frame, which is way fast, but something I do with for loops, because again, that's what I learned first. So if you have one simple thing you want to do to a bunch of things, apply is great for that.
Hey, Kim, can you explain why you did not use the curly braces after the function here?
Here, yes. So if we look at apply, the parameters that you can give it, I'm doing shorthand here. Like I didn't say that X, so really it's, that X equals this, and function equals this if you're going to give every single parameter. So because it's inside of the supply function, you get to do shorthand without the curly brackets. And there's a lot of functions in R that use, functions inside of functions, and simply to have fewer brackets. I actually don't know if it'll run if you put curly brackets. Oh, that works too. So this is one of those cases that you can remove them because this function has specifically allowed you to remove them. And that's always, if you want to see those sorts of things, going to the help page and looking at the examples to see. So like here's a function, example, and they don't use the curly brackets. So I know I don't have to, but it appears, and I didn't know that you can use it. So
thanks. It's just a question that I've come across before. So thank you for explaining.
I have one additional question, if that's okay. So I know that for the purposes of this workshop, X divided by 10 is relatively short to fit in there. If this was like a project that you would be working on, something that's a little bit more bigger, complicated, how do you prefer to structure it? Do you have like the functions at the beginning of your script? Do you have it like in a totally separate script that you run in source? Do you just keep it like within the apply functions? How do you like to do it?
It's a good point. Like you said, this is short, this is easy, it's one little line. When your functions get really long, my preference is to put them in a separate spot. If you're working in a script, it's often easier to just put them at the top of the script. Because of just the nature of my job, I do almost everything in R Markdowns, because almost everything I do is going to be given to someone who doesn't code to see the results from. So I like to then go even further if it's not just in a separate part of the code, it's in its own script. And then you can source it from that script. There could be in some other, so like some other script has my function. And then function of X divided by 10. And then I would here, just keep it, this won't be any shorter, but if it were, then here, instead of writing out, this thing, I can do my function. And I don't remember if you have to have X or not. You do. And now it's angry. Of course, I tried to do something on the fly, and so it breaks. I'd have to think about for a second why that's not doing a thing. So yes, I like to separate it because it can be really hard to read in here, and it's a lot easier if this were doing what I wanted it to read my function.
I think if you didn't have the curly the parentheses with the X, and just left it as my function, that may work.
Yes, there you go. Thank you. So that makes sense because it's using these data into the function. It doesn't need you to tell it a placeholder of X. It already has a placeholder in the function. So that's apply functions. And again, so this is like a whirlwind, like one example of it, one example of another. So before we switched to yet another way to do this sort of thing, or any other apply. Okay, we'll talk more about apply at the end actually as well. So it will come up. So another way to do almost all of the same things that apply can do, sometimes about the same speed, sometimes a little bit slower, and sometimes ridiculously slower, is in the tidyverse. So, and I'll show you that this might be slightly longer to run, but if you're already working in the tidyverse, it can be very beautifully, rendered and easily understood code, which is why I like it, because I'm always already in the tidyverse. So we're going to use the mutate function. In the notes, there's some info on some of the other functions. I have a whole 6-hour workshop just on tidyverse. That's how much I love it. But we're just going to use mutate to do exactly the same thing as apply. So the way mutate works is like any other function. So we're going to name this a new thing so we're not overwriting our other version. So it's mutate function. We give it our data. Again, because this would be going into the loop at this stage, we use the filter. I guess it would make more sense to call this dat filter centimeter mutate. That's too long. Let's call it dat mutate. And then you can list as many variables as you want. So fill length centimeter. Oh, I'm going to run out of space. New line equals fill millimeter divided by 10. And then I'm gonna copy that because I don't want to type. Fill depth. Oh gosh, why do I always do that? Length, 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 depth, depth. Okay. So you can, continue to list as many variables as you want to change. And so the first great thing about this is that there's two great things about this over apply. The first is I'm not subsetting my data. I'm not getting a separate data frame that's not connected to my other data. So if you're paranoid like me, I'm 100% sure that the order of this variable is the same as the order of the samples in this variable and all the other variables that I'm not changing in the data frame. And mutate gives you the chance to rename the variable for clarity. So if we run that, I actually don't need to look at the full data frame. Scroll up. We see that we still have our old measurements. And then at the end of the data frame, we have our new renamed measurements. Now, again, this is technically one line of code versus the two, but we can actually make it even better because just like the question about, well, I don't want to, type out the 3 species was if I don't know what they are, maybe I don't, know what all of my variable names are, or better yet, there's just 30 of them and I don't want to type out 30 equations like this. So similar to apply, mutate has across, which applies things across columns. For this case, mutate only really does what apply can do when it comes to margin 2, when it comes to columns. If you're modifying rows, that's much easier in apply and not a thing you want to do with mutate. So, oops, not capital. Across looks like apply. And for those who are familiar with the tidyverse, across is a new thing. There used to be functions like mutate if, mutate all, which still exist and can still be used, but the moving forward is these across functions. So I wanted to show them. I'll also show the mutate if, because that one I still use even though it's going to be depreciated and go away. So dot mutate, we're gonna mutate. And setups like this, that you mutate across, and I'm gonna make this pseudocode because it can get a bit hard to read. So forgot to put my data in. So you mutate across vector of variables. Again, not real code. And too many lines. And then your function. There we go. So you give it your data, you say across, and then within the parentheses for across, you give it what you gave it before, but as a function now. I'm actually going to make that into code. Dat filter across, trying to be helpful. So you can see here, it help across columns. It automatically does everything, and then you give it a function. We don't want it to do everything. So we're going to give it our fill length centimeter and fill depth centimeter. Oh, almost fits. I'm going to just continue to make this smaller so it fits. And then we're going to give it a function. Just due to purely the person who wrote the code, this parameter for function is fun, all caps. Inside mutate, it's .fns. There's no real meaning behind that. It's just different, and it's one of those like little things you have to remember as you're switching between them, or go to the help page, because I as well forget, and I try to use fun for most things, and then if it doesn't work, I have to go look it up. So we give it a function, and another small, syntax thing is to tell it it's a function, we have to use the tilde. And we use .x instead of just x. Again, simple requirements of mutate. So now it's saying across these columns, do this thing. And just like this, it's going to keep them in the same data frame, make sure everything stays in the same order, which is one thing I love about it. Of course. Mutate is angry. Do I have a typo? Oh, centimeter doesn't exist. Whoopsies. So they're millimeters right now. They're not centimeters yet. So if I do call names, we see that just like apply, it hasn't changed the names. But the data are different. And just to show that, so we're like 100% sure that this has actually happened. If we look at the pre-change data, the millimeter, I'm just going to look at the first 5 versus dat mutate fill length 5. So they are divided by 10. So unlike apply, where in order to automatically change the name gets a bit difficult, mutate has a way to automatically change names. Like I said, this across is really new. And so currently all you can do is add a prefix or a suffix to the name. So I can, add centimeter to the end of this, but it will say millimeter, centimeter. So that's not beautiful and great. So in a short thing like this, I would probably do this to make the names exactly what I want. But oftentimes you're doing things like this inside of a loop. I'm never actually going to look at this data frame. I only really want the plots. So the fact that they're called millimeter, centimeter won't matter. We can make it do some automatic naming. So I'm going to copy this because it's almost the same. We're just going to add to it. So now still inside of the across, because we want to, again, still apply this renaming now across. It's .names, and now we're going to give it basically a function to rename the columns. Tidyverse, particularly mutate, calls a column, the placeholder for a column name is swirly brackets .call. You can't pick your own like X and I, so that's the placeholder for any column name, and then we're going to add centimeter to the end. Column names. And now we see the new ones don't overwrite the old ones because they have a new name. And like I said, those names are not beautiful. And if I had to actually like look at them, I'd change them. But we're just going to plot from them. So in the end, you can maybe live with it. Sometimes I don't, and I change them and it's unnecessary. But I encourage you, you don't actually have to look at it. Just make it so you know it's different and accept millimeter, centimeter.
Yeah, I have a question about the curly braces. The dot cols in the curly braces, is that just syntax that you just have to remember? Or is this something, are there other variations of it that you could use in names?
This is, I don't want to say there's no other way to do it because I'm sure there's some flexibility. It's one of those ones for me that I just remember that Tidyverse calls column names in this way. And when I forget, I go to the help page / Stack Overflow, which is what I had to do earlier this week because Mutate Across is new and I've never automatically renamed until right now with Mutate Across.
Yeah, I guess, yeah, there's always so many new changes or lots of little changes. It's hard to keep track of all the new syntax.
Yeah, it's one of those reasons I think why they've left the other mutates there, particularly because, you know, Mutate Across takes more words than Mutate All, but does the same thing. Oh, some bad cat behavior behind me. So, yeah, and like I said, it's only prefixes and suffixes right now. It's not a full rename, but I'm hoping that the next update or a soon update will allow you to just completely like replace parts of the names. Would be great.
Oh, we have a question asking, is across very new in the Tidyverse?
Yes, so when our 4.0 came out, the next Tidyverse update after that was the first time across was there, which is why I want to show as well. So if like you have an old version of Tidyverse, this code might not run for you. So the old way is using, so there's things like mutate all with, and then mutate at, mutate if are the main ones. So all columns, similar to the default of apply, at, which we're going to use where you say specifically which columns, and then if, which you do an if else statement, like mutate if is numeric would work for this if I want to divide all of the numeric variables by 10. Although I think some of them, so then it would potentially divide year by 10, which we don't want. So the old way, but the completely usable and sometimes easier to read way is mutate at, and then it's our dat filter, and then you give it what you want to mutate at, the different variable names, and then you give it your function. I haven't tested this. Oh, why are you angry? And this isn't the notes, which is probably why I'm missing some syntax thing. So you see superseded, meaning there's a new way. What am I'm forgetting? Do you not need the swirly bracket? Or am I in the wrong order? I think I'm just in the wrong order. Where's the examples? There we go. I think I just have to tell it that they're variables. Before I explain what this means, I want to make sure it runs. Whoa. Yeah. So again, a small syntax thing that I completely forgot is that in order to make sure tidyverse knows that the at parts are variables, the vars are variables, you have to list of columns generated by vars. So you have to tell it that it's variables, which I forgot, but it does the same thing. And you can add an automatic renaming as well, similarly. I saw like the chat moving. Are we all good? Yeah, okay. More on the tidyverse because I could not help myself. We got time to go into this. I'm going to copy paste directly from the notes because it's more important to go through the steps that they're doing as opposed to typing them out for time. So the reason, not only is this one line shorter, than doing the two separate, vector making. The reason this might be really helpful to you in a for loop is that for loops can get long and they can get complicated. And so, as actually any code can. And so mutate really comes into play if you're already working in the tidyverse. So we already had this filter step where we were getting our ith species or first, second, third species. And so tidyverse can be piped together, which is this symbol, and do all of that at once, which again, this is technically one line of code because of the pipes, but it's spread across to see. So this is where mutate might be the most useful, is if you already have filtering or other sorts of steps that you have to do before or after, this allows you to do it all at once, where it's going to take your data, it's going to get filter to just the first species for the first one. It's going to do the mutation, and then it's going to, all of that's going to go into dat filter. You don't have to make dat filter and then dat filter centimeter. It just saves the dat filter, and then you can use that to make your plots. So just to show you that this works. Oh, we're still set up so we see all 6 plots at once. So to undo that, there we go. All of our plots. So we don't really have time to go into like the full tidyverse, but it's just more if you're going to be working in it, that's when mutate can be really helpful. And mutate across under the hood uses apply functions. So it is as fast very often. So if you're already in the tidyverse, it goes really nicely into the workflow. If not, apply is also a great way to do this.
Kim, can you explain this magic that you just did with the par functions?
Yes. So this is when where did it go? It's somewhere up there. That early on I said in the notes, it was, it took up way too much space to print all 6 plots in their full form. So in base R, you can tell it to make a grid of, rows by columns with this parameters, MF row, which I've always wondered why that's the parameter name, but it is. So you can say, if I did 2 by 1, so 2 rows, then ran it, then every plot. And what it does is once it runs out of space, it starts a new one. So it prints the first 2 plots because I gave it 2 rows and 1 column, and then it ran out of space. So it started a new one and printed them like that.
Nice. Thank you so much.
Yeah, that would look a lot better. Well, that's still not great. Small screen. So this is, just my plug for, I love the tidyverse. I think it's very readable, although across is kind of the limits of readable. Okay. So next up, we're going to return to loops because we see here we still have a repeated code, even in this beautified tidyverse one, which I'm going to shrink that down with a little caret. So people who work with big data would be very unhappy to see me type that, because what we're about to do is the slowest way to do things. So a single for loop, with a lot of careful coding inside of it, can be really, really fast and work really great. Double for loops, which we're going to do nested, very rarely are they a good idea. And so I would say if you feel like you need to do what we're about to do, really sit down and think if there's a mutate or an apply, or running the loops separately could be done, because this will run quickly because this is a very small, task we're asking. But if it was a large task, this would be the slowest way to do it. So what I mean by nested is we're going to do for, and I'm just going to make the skeleton for things, and then for other things. So nested. So in our case, it's, and I'm going to not use I anymore because that, some people use I and then J, then K. I find that confusing and I'd rather type out what it means so I don't get confused. And I'm going to leave this as a skeleton up here as well. So let me not do that.
We do have a question. How did you collapse the loop?
It's very hard to see in the black background. Yeah, there's a little caret here, little arrow, that whenever there's swirly brackets, curly brackets, trying to make myself stop saying swirly, curly brackets, you can collapse everything in it with this.
On a side note, is there a shortcut to collapse everything and then unfurl everything at once?
There is, and I don't remember it, but I remember somebody doing it in a workshop and being like, I should write that down, and then I didn't.
Yeah, I'm super slow, so I don't know if there's a way or not. So I go through the script and I click through every single little triangle.
I feel like there's got to be a way to collapse all of these headers too. I'm going to write down to look that up and put it in these notes. / ask the person who I remember doing that workshop. And so yeah, the carets work for these when you use the at least 4 hashtags as well to collapse these. And then you have your basically like a table of contents right here. Oh, also another trick that using these headers is great, because if you go down in our studio here, it automatically it automatically makes a table of contents. So now I can like, oh, well, I want to go to the apply functions, and it'll take your cursor there, which, that's not super helpful when they're all collapsed, but when you're in a big long script, as well as it makes a table of contents here for you to work with. So the hashtags, and for some reason it's also putting function in there.
So apparently it's Alt plus O, so Alt and O, and then Alt, Shift Alt O for expanding, then Alt for collapsing.
Okay, that's how I open files. Ooh, Option. Nope, that's how you make a weird 0. Nope. Well, it doesn't like it on Mac. Function O? Nope. What was it on? So it's...
I posted it in the chat, so...
Okay, great.
I wonder if you have to...
If it's not Alt, if you're on a Mac, maybe it's Command?
Yeah. Yeah, if you go to the Edit tab and then go to the folding, it'll show you what it is.
Yeah, because for us, Command O is open.
Yeah. And then if you scroll to folding, yeah.
Oh, that's why I don't do it. So it's Opt, so it's a triple. Opt, Command L. Opt, Command O. Okay.
Some of those symbols look like cryptography sometimes.
Like it's wingdings. Yeah. It's even better when you have a PC keyboard working on a Mac.
Also, Ciara writes in the chat that according to a developer, Paul Morel, MF-row stands for number of multiple figures. Use row-wise. And there's a really cool link there.
Oh, thank you.
Of course, it's a New Zealand prof. Ooh.
Multiple. That's great. Thank you. I've always, like 10 years later, still just like had to remember MF-row as a weird string of letters. Okay. I'm just gonna make my skeleton again so we can add to it. Okay. So to get back on track, nested for loops, often not a good good idea, sometimes a necessary evil. So I'm going to say for penguin species to be descriptive in our unique dat species. So for all of those, and then for our variable I'm going to list fill length centimeter, and I could do this without listing exact because I'm doing a subset of columns. It actually would take more words to say, you know, unique, or to say column names and then say which column names I wanted. So in this case, just typing them out is the easiest way. If you had a really long list, then it might be worth, what I would do honestly is in a thing beforehand, you know, make a variable vector and then list them there and then put it in here. So it's a bit easier to read, but that runs exactly the same and isn't any faster or slower. So here I'm just going to list them. So for our penguin species, do these things, and we're just going to go back to our base R version. So now we're actually going to run the code. Come on. Do all the things. We're gonna actually, finally replace with our, or we don't want to use that one. We're gonna use the apply just to see how it works. Which now we're in a data frame, so now we have to change all of these. Actually, no, I'm not gonna do that yet. So just to show you, we're into the nested loop. We're gonna loop through all the species, and then we're going to loop through our two variables of interest, which is great if you then are doing lots of variables. You just add one more to this list, and we still need to, these are the base R versions, so we have to change this to penguin species. So filter, apply our millimeter, right? So but now we don't need to do it over these, and I specifically wanted to put the apply in here to show you that like you are undoing, like I said, we did a loop, we did apply, now we're going to get rid of, that apply and do another loop, and then we're going to get rid of the loops. So back and forth. Anyway, so really what we're doing here, right, is now we're using variable, but now this is only one variable. So apply isn't helping us at all. So now we can actually just go back to the original way, which I shouldn't have deleted. Because we're doing a second loop, now we can just say, okay, now you're going to do the variable. And we're going to give this a generic name, like size. And we're only need to have the plot once, and we're going to put the size label in there, penguin species in here. And so the double loop is, I think, the cleanest one to read so far, because you could say, for all of our penguin species and for all of our variables, get our penguin species and then change our variable in centimeters and now make the plot. And that works for this, but like I said, in any larger data sense, this would get very slow very quickly. I will also say that because of the way loops work, this will not work, and I wanted to show that. So because we're working in a loop, it can't find variable, because what it's literally looking for is a column inside of dat filter whose exact name is the word variable. So because I don't want it to just use variable as the name, I want it to go and get what the variable was from the loop. Let's round this, round with parentheses. And I use the word get specifically because that's how you do it, is you say, don't insert the word variable here, go get the variable that I'm using as a placeholder for these other things I'm looping through. And the other thing is now this label is going to be wrong sometimes. So if I put variable here, now it will automatically label it. And here we don't have to use get because I'm not going into the data to get it. I do want it to just print the word. So let's see what this does. And still gonna leave it 2 by 2. Because it's angry. Why? Oh, it's because I was in the tidyverse in the example. This is where you get to see why for loops are really annoying and why sometimes syntax. Oh, now it's really angry. And why I always work in tidyverse. Not why, but this is why I don't remember. Oh, so it's still having the problem that, yeah, it can't find it. And there are several ways to tell it. I was trying those double. Let me go to my other old notes. I forget the exact syntax. And we have, unless somebody, one of the moderators remembers, which if it's single exclamation point, double.
I thought it was bang bang, but that wasn't working. Or as underscore name. I don't know if that.
There, as name. Oh, I just have looked this up. I will say this is probably the most annoying part about for loops is figuring out how to use things like a character string, like a word, as a variable and vice versa. Why?
Laura in chat suggests double brackets. So I think this is a good time if people want to try troubleshooting this actually.
Oh, sorry, cat.
Also, Kim, if you want to take a break soon, we can do that as well.
Yes, I think actually that'd be great. Let's do a break while I also try to figure out which was, because the other way was tidyverse, the get way.
Awesome. Let's say about 10 minutes, if that works.
Yeah.
Awesome. So we'll be back at 7:32 or so. And feel free to try and troubleshoot on your own and play around and see if anything works.
That's a tricky one. I'm not really used to combining it in base R, so I'm more familiar with tidyverse as well.
Yeah, so I immediately went to get, and I was like, yeah, get is how you do it. No, it's not. This is one of those Google pages where at the bottom it says you visit this page frequently, and you're like, dang it.
It might sound dumb, but sometimes rewriting it from scratch can can help a lot.
Sure, I've done that a few times and I go, wait, what was different? I don't see it, but it worked after I rewrote it, so I just leave it alone.
Yeah, sometimes if I'm trying to integrate somebody else's code into my code, I won't be able to do it. And so I'll just rewrite the entire thing from scratch and it'll be a lot faster. Chioma in the chat writes, and I hope I pronounced your name correctly. Says get variable for me. So could be the package hasn't been installed.
Oh, get worked.
Oh, worked.
Yeah. Attempt to apply non-function. Oh.
I guess you can just run get to see if. Oh.
Nope. I mean, get I think is base, so it has to be there. Oh, I've tried all the ones I know, eval and exclamation point.
Maybe bang bang then get. I don't know if you tried that already. So
yeah, here.
If you had get back there, but then bang bang just before get. Oh no. You had it.
Chioma, if it worked for you, do you actually maybe want to post your code in the chat and then we can try it out? Have you tried just get variable?
Then it won't have a data frame to go from. Get. Oh. Well, it found it now, but it says it doesn't exist.
Oh.
Did I type it wrong? Is that the whole thing? Did I spell something wrong?
Are we going from millimeters to centimeters?
Oh my gosh. Yep. That's not the variable name.
It's hard. It looks so similar. I didn't notice it till now.
Okay, well and I'm curious if that old way does work.
Yep.
And in the chat, we have a pretty big question from AD. Could you do a quick review of some of the syntax differences between tidyverse, working in a data frame, and sort of using base R, since this is a big question that's asked a lot?
Yeah. I will definitely incorporate that whenever it's back. Good point.
So Kim, one thing that you could try is so after dot filter $, bang bang as underscore name and then variable.
As name, yeah. I think this might have. Yeah.
Oh.
So I think that will work though, because we're playing around with the two. That because here's what I don't understand about base R, and that this works, but the double brackets is equivalent to the $sign, but doing a $sign with variable doesn't work. One of those little things.
Yeah, there's some things that are still a mystery for me.
I think the mystery for me is that the fact that the double brackets automatically figures it out, like why can't the $sign automatically? Or like have an if statement, like if the word variable doesn't exist, then check what it means. Oh, hello.
I find that base R is slow to update those kind of issues. Oh, hey, Katie.
That'd be a little famous.
Yeah, like base R is so slow to change these kind of things. Like we only just had like, what was it? As factors equals true is now false for the first time since forever.
Yes, I love the tidyverse, but I always forget whenever I'm working with genome data because it reads the chromosome and it's like, this is a number. And then it gets to the X and Y chromosome and it's like, I don't know what to do. Dang it.
I should show you my cat too. She looks kind of like yours, but with longer hair.
It's our dream that Claire will be long-haired. It's the dream.
Seems like we've started collecting the cat tax.
Oh, another little tuxedo.
This is Zara.
Aww.
I mean, one of my favorite stickers is the Our Cat Ladies sticker. So.
Yuka, I actually didn't know you had a cat. I always thought you just had a dog.
Yeah,
no, well, I mean, Claire's
new thing.
Yeah. That's how many people have a new edition since quarantine? Because that one's new.
Yeah, I only started going back into the lab like 2 weeks ago, and I feel so guilty that sometimes he sits at home for just a few hours and I'm just like, my heart's, yeah.
Yeah, I keep getting invited back, like, hey, you could come into lab, there's space. And I'm like, nah, there's a cat here, there's 2 cats here. My 17 types of tea, I think, it's unreasonable. Oh.
Yeah, I'll be right.
I think we're good to end our break. I know AD asked this question earlier and we kind of answered it in small bits, but I guess Kim, if for those of you who had stepped out for a break, if you wanted to go over some of, I guess your like maybe top few main differences between tidyverse and base R, I think it would be helpful for people. It doesn't have to be everything because there's so much.
There's so much. Yeah, I should make a cheat sheet list to just always have. So with the loop, what we found was that using double brackets. So in theory, that filter, the $sign variable, is equivalent to this with the double brackets. But because we're in a loop and variable isn't actually the variable name, we need to use the brackets because it automatically looks for not variable, but looks for this. And on top of that, if people were typing along with me, I had centimeters up here, which is not the variable name, which is the problem. So just to prove that of course, my figure margins. Yeah, so now it'll run. So that double brackets is, I think, a good example of, so like base R versus tidyverse. particularly in loop functions like this. So first big one would be, right, use a character string, so like name, as a variable. And so tidy is get name, base is the data, dat, let's call it dat, bracket, bracket, name. So that's one of the big ones. There are also times, I hope this is probably make it easy. There are also times where it's name. If it's not inside of a data frame, if it's like a vector name, then you can't use brackets because brackets are specific to, in this case, this data frame. So base in a data frame, and then separate these. Base is a vector. So that's a big one for calling variables, particularly inside loops. I think if there's any other things we've touched on that's more just syntax. Oh, the functions. So calling a function was the other big one. Calling a function. Oh, so typing. Tidy. So in mutate, it's dot funds. I'm actually not going to make it a, so in mutate, it's dot fns, and the placeholder then is this dot x, or just dot, actually. I find that confusing, so I always put the x, but if you want to make your code the shortest possible, base apply, use fun, and placeholder, whatever you want. Probably use x because that's the shortest. Are there any other, does anyone remember any other weird syntax things that differ? There's the functions, .x. The only other last one that we haven't really covered, but I think is important to note, so like not in a loop, when you're not dealing with something weird, that tidy doesn't need the surrounding quotations. So that's another big one, is that when you're working in the tidyverse, it's ever so slightly shorter, unlike base R, where when you're listing these, you know, they're in quotations because I'm going to use them as a variable name versus, so you can see that actually, I see that. Oh, okay. Why? There. What happens when you squish your figure way too small? Okay, anyway, that, you know, inside the tidyverse, there are very few quotation marks used, I would say. So if you've ever using them in base R, there's a pretty good guess that you either don't have to in R, in tidy R, but that just makes it shorter. It often still works even if they are there. So those are the only ones I can think of. I think I'll ponder this more and add to this when I upload this if I can think of any other big differences. With that, we're going to move on to the last kind of way to, not the last way, the last way we're going to go over to optimize these repetitive tasks. So like I said, double for loops, dangerous because they're very slow. There are ways to make them faster. So for example, right, like every time there's a new penguin species, I need to do this filter, but I don't need to do it every time there's a new variable because the penguin species doesn't change. So if I moved this to before, so now it filters once, and then it uses that same dat filter for all of my variables. That will be faster. And there's other ways to just continue to like make this as fast as possible. But sometimes that's just not enough, and there's no way around using the for loops. You maybe have apply functions inside of your for loops. You're doing everything you can, and it's still just taking forever. This happens a lot in my world of billions of sequences and hundreds of samples. And so one way to speed things up is just to run them in parallel. So it's to take your loop and say, okay, I have 3 species. Let's say I was doing a bunch of calculations for the 3 species. If I could run each species on a separate processor, which having 3 processors is not even a huge machine, then it's going to be about 3 times as fast. So a third the time. And so we're going to do that. And this is already, really fast, but we can make it even faster by saying splitting up our 3 species onto multiple processors. And that's what the last 2 packages. So for each and do parallel work together to do things like for loops and then split them up. And it's just slightly different syntax. So a for each loop is set up a lot like a for loop, only it's for each. And instead of saying something in something else, it does I equals. So instead of I in our list, we have I equals our unique dat species. So doesn't take the in, takes equals instead. And instead of just using swirly brackets, because we're going to tell it to run on multiple processors, we have to say do parallel. It's from the do parallel package. And then we have our swirly brackets, curly brackets. So this does the exact same thing. So it's just for direct comparison. Same as for I in unique dat. So they're equivalent. It's just now this is going to split this across however many processors you told it to do, which we're going to do that. So we can take that. And we're going to take our loop that worked. So let's take this one. Or no, this is the double loop. Don't do that. We're going to go back to the last loop. Let's use the tidyverse one. You can use any of the loops that worked. And you put it in here. I will say you could also nest for each loops. In general, that is not a good idea, because what for each is doing is it takes your entire environment, so everything you have here, and it copies it for each processor to work on. So unless your data are really tiny like this, that takes time, first of all, the copying. So that's why sometimes for each actually takes longer. If you're only doing 100 processes, it's actually usually longer to split everything, copy all the data, and then run it than to just run it on one processor on one copy. As well as it takes a ton of RAM then. It's going to have a copy saved in RAM for every single processor. And that's more likely than not for R. R is not designed to work with RAM efficiently. So it's more likely that you'll run out of RAM on your computer than it is you'll run out of processors. So if you're going to do something like this, just like testing a loop, it's a good idea to run on one processor, maybe run 10 samples and have some way to monitor your computer open to see, okay, at its worst, it's using 10% of my RAM. So I really shouldn't probably do more than 9 processors, because that's 90% of my RAM. Not that I have 9 processors on this machine, but things to keep in mind of this will make it faster, but it will make it use a ton more RAM if your data are large. So do par comes from the do parallel package. Yeah.
Quick question. So how can someone check how many processors they have on their laptop or computer?
Yeah. So for Windows, I don't actually know, but for Mac, no one believes me that I used to be a Windows person. For Mac, if you do the Apple symbol and about your Mac, come on. We can see here that I have a quad core. So it means I have 4 cores, and the way Macs are, almost always they're also mirrored. So I really have 8 cores that I could use. But like I said, I only have 16 RAM, so that would break it. For Windows, does anyone know a quick way to look it up on Windows or Linux? Go to system information. Another thing that both Mac and Windows have things like activity monitor. So I have mine saved here because I use it so frequently. It's just under the applications utilities or program files utilities in Windows. That one I actually do know for Windows. Oh, it's on the wrong screen. Okay, come on. There we go. So this is another way to check it. Here's all of my CPU. And if I double click, I can see here are my 8 potential cores.
We also have another suggestion. So in the parallel package, there's a detect cores function.
So just inside of R, you can do it. Let's do it. Nice, inside of R. So yeah, you can ask R. That should have been our first response. Ask R.
Yeah, and one more way that I can think of is through terminal doing htop. You can sometimes see how many cores you have.
It's more than likely, unless you've specifically built like the largest laptop you can make, like this one, then it's always safe to run on 2 cores. If you're starting to think about running on 3 or 4, then yeah, definitely do this and be checking. The question is, why is it important to know? Because if R is actually smart enough, this do parallel package is smart enough. If I told it to run on 9 cores and it didn't find 9 cores, it would just run on 8 because it can figure that out. There are some programs, some packages in R, as well as just other command line programs that aren't smart enough, where they try to run on 9, and then whatever's supposed to be running on that 9th processor never gets run. And if somebody wrote a nice error message to tell you that, that's great. But sometimes they don't, and sometimes it doesn't even like fail. It just runs 8/9 of the data, and you get an output, and you don't know why a 9th of it is missing. In our case, the reason it's important is not because we're going to run up to that many. It's more just to keep in mind when you are going to go near the limit. You use all of your cores, it might still run and finish, but it's more likely you'll actually run out of RAM, which the other tab on here, which I'm barely doing anything, and I'm still using. Well, that's a lie. There's something running in the background.
One, I suppose, quick question. I know that a lot of our users don't really pay attention to parallel programming that much, just because there's not really that much of a need. As somebody who clearly does, I guess, what are your thoughts on Julia? Because I know it's such a hot topic right now in terms of parallel programming, and if you have any thoughts and comparisons, and if you've ever tried, doing the same thing in Julia and how you found it.
My thoughts are that I've also seen that, and it is on my to-do to learn some Julia. I've not done anything in it. Like I said, I do everything in R Markdown, probably even when it's unnecessary, and I do everything in R because it's where I'm comfortable, even things that I know would probably be faster elsewhere. And for each in particular for this is one of those, when you're in this in between, like you could rewrite everything and make it faster somewhere else, but if I can just take my 2-hour process and put it on 10 processors, then I don't care. Then it's fine that it's inefficient because I can split it up. Actually, I realized this is a bad idea. We're not actually going to copy paste. We're going to start from scratch because there's some problems with for each that we need to talk about. So the first being that we can't just copy paste all of that code in, because for each, because it's on multiple processors, it can't use the plots pane here. There's only one plots pane. And so when you have multiple processors running, it can't print to it, because not every processor, like if they both try to print at exactly the same, second, what is it going to do? And it just, so for each cannot use the plots pane. So instead of doing that, we're going to save them, which is why you'll see on the GitHub that there's PDFs labeled by the species, because we're just going to save them as that instead. The other part is we have to tell it how many processors. So and to do that, we do register, do parallel. I always forget what the capitalization is, and tell it how many cores is the terminology. So we're just gonna do 2 because we said this is already really fast. And this is importantly for the rest of your session in R. So if I ran 6 for each loops, one after the other, they would all use 2 processors unless I changed it and set it elsewhere. So I think this will stay the same. That, see how well I remember it, species, capital. Nope, it's an I because we're in the loop. And then this is the point where, because I'm splitting on multiple processors, using apply versus mutate versus like that, it doesn't really change anything. So I'm just gonna go back to the base R one just as an example. But you could use any of the apply, also partially because I don't want to copy paste it, and I can write this one. Then bill every time. Someone should have clocked me if I ever did that correctly. I don't think I did. Length, centimeters. And now, because I can't print them to here, I have to save them. And so I'm going to do that by making a PDF. You can also do PNG or JPEG. And I'm going to make it dynamic. So I don't want to just call it plot, because then I'm going to make a plot for each species and they're all going to overwrite each other, and that's not going to be helpful. So I find paste function to be incredibly useful, and paste 0, meaning don't have a separator. So I want to paste I, so the name of my species, and PDF. And so just to show what this does, we're going to print file name just to show you. So what this is doing. And of course, something's
We do
angry.
have a question from AD. So if you don't specify the number of processors, will only one be used? So is there like a default?
There is a default, and it's probably not in here anymore. When you first load the package, it tells you how many, and it does that by detecting on your computer and then doing, I believe, 25% rounded down. Yeah, I don't think we can go back that far in my console, but yeah, when you first load it, it tells you what it's going to do. Oh, okay. I accidentally had sex here instead of species. So it's always good to check your file names, because it's not. Let's do this the slightly longer way. Paste 0 and I don't have a good relationship. Well, I don't know why that's not working, because in my example, it prints them. Paste. Oh, that's why, because it's making a PDF. So I just want to show you like why paste can be helpful to make these automatic names, and I accidentally was still trying to write a PDF. Always check. See, I forgot to put a period in between this, so this would save as a crazy file. So period there, but so this will automatically save under when these have the period in them, these correct file names, which is how we ended up with oh, not in a project. How we end up with 3 different files. You could end up with 6 different files, and you could paste I and then do a loop through the variable name and all of that, but we're going to do 1 per species in this case. So just to make sure that period is working. Okay, yes, I'm going to get these 3 files. Good check. And use the assignment there. I'm going to leave this in here for reference, but we're not going to run it. So I'm going to comment it out. And so we're going to make a PDF. We're going to use file equals our file name. You can also set height and width here. We're just going to let it do automatic. And then because it's the same as an old loop that I have up, then I'm going to make my 2 plots. Again, you could do another loop and make these dynamic, but this is really one of those moments of thinking about, I could make this code shorter, but actually less efficient by doing a for loop inside of my for each loop. Sometimes going to base R and using vectors, actually almost always using vectors, is faster. You're not going to see it here because it takes a second to run, but trust me. And there's a link at the bottom in the concluding thoughts of the notes that Pat Schloss literally this week just did a discussion of for loops and specifically showed taking one that took, would take like 100 days to finish and had it made it run in like 25 seconds, which was amazing. Doing things like keeping it simple with base R and not nesting a loop in a loop and things like that. So I think this should be it. We have for each, we have our 2 processors, our species, filter, convert, save. And just so you can see it happen in real time. Nope. This is my folder where my script is. You can also write a file path in here if you wanted. It'll automatically save wherever your R script is because we're not working in a project or anything. If you were a project, you would save it in the project directory. I think the last thing is that we're putting 2 plots and we want to make sure that our parameters are correct. So I do want to make sure they're already set in my, in my console for my window there, but I want to make sure. Do 2 columns. So we'll have bill length next to bill depth for every species. And they don't exist there. And hopefully, oh gosh, it saved them somewhere else. Device null. That means it made no plot. This is where we find the typo.
It says sex again instead of species in your plots.
Here we are doing sex for the X variable though. Is it somewhere else? That unique species, dupar. Millimeters. Paste. We checked that worked. Huh. I honestly don't know what it's doing. Let's see if it gets that far.
Where is your working directory?
Yep. So this was the last project I was working on. Let's go see if it's there. Yay. Good call. So here are my plots.
It works.
This is a completely different place. So I'm going to do a shortcut. We go session, set working directory to the source file location. And that just does set WD for me, so I don't have to type all of this out. And now we hope that it does the right thing. Okay. Yay. Correct. Yeah, I was working in a project minutes before the workshop. So now we have one plot for each. And as I kind of started out with, right, this doesn't actually take that long. Do we really need to write a loop for it? No, but this is so easily scalable. Any of these options are to, if you just had more species in your data, this would just make a new file for every single species, no matter how many you had there. So that's all I had for the code options. And I kind of just wanted to like summarize. So a lot of what we talked about is personal choice as well. Like I said, I work in the tidyverse, so I tend to use mutate. Now that there's mutate across, I'm trying to use it, but I still go back to mutate if and things like that, the previous versions. Really comes down to what works in your code already. Don't learn the tidyverse just to learn mutate. Learn it because it's going to help you in other ways. And I just can't say enough positive about apply. If something's running slow, if you can make some portion of it into an apply function, it gets so fast. Particularly for me, linear modeling, when I'm running millions of linear models, it's unreal how fast apply is at doing that. And the other big thing is if you do any Googling on this, you will see some very, very mean talk about for loops. And I'm here to say I'm a bioinformatician and I use them almost every day. So don't listen to them. If they're useful to you, and even if they're a little slow sometimes, they can be very useful. And I love that there's the curly brackets and you can have, a whole mess of things in there that cannot be done in even a couple apply functions. So don't listen to them, but also be warned, there are a lot of people who really hate for loops, a lot. And with that, I think just any other questions on the content, as well as just any other questions or things you want to see about automation that we have time to live code it?
Not a question, but just a comment that if people kind of knock you on using for loops, just know that like a lot of the packages that you use, if you go to their source code, like on GitHub or wherever, like most base like packages actually are written with a lot of for loops in them. That's just how writing packages kind of go a lot of the time. So
yeah, I'll, like add to that it's for loops are based R. So a lot of times if you want your package to not be dependent on the tidyverse, because if somebody changes something in the tidyverse, like gets rid of mutate if someday in the future, then if you're using mutate if in your package, now it doesn't work, versus loops are always going to work.
now, if else on the other hand.
Is that a comment for or against if else?
Tanya asks, is there a particularly nice video tutorial for apply /tapply /sapply /lapply? So is there a good resource that maybe you have on hand?
I don't have a video, and actually before this I was trying to find a good tutorial, and to be very honest, the best one I found was DataCamp, and I didn't want to put it in the notes because of problems with DataCamp as a company. So no, I don't have a good one, and that's on my list to try to find and add. And also I will open up the on GitHub, this is a public repo. So if you have things that you found useful, feel free to put them in a message on the GitHub for others to see as well.
Kim, have you used much of the per package?
I mean, that's part of tidyverse, right? So technically,
yeah,
not
so as a way of, I guess, as a way of replacing lapply and the other applies.
I have not. No, I'll say the Mutate and I have been really hanging out for some years now, and it's I need to expand. But
yeah, it's one of the more relatively newer things I'm trying to learn is the per package. I don't know if it's faster or slower than apply, but I have a feeling it might be a little slower. But syntax-wise, it's always much easier to read for me.
Yeah, it's my current beef with across, that it isn't as easy to read. And there's something stealing from the chat that somebody else also posted. Oh, there we go. This, our bloggers using apply, sapply.
Yeah, it's I don't know, maybe it's a controversial thing to say, but it's just the reality of programming. Sometimes you don't need to know the really nitty gritty of a function to be able to use it competently. You just kind of gain experience as you go on.
Very true.
Yeah.
When you reach the point where you're reading the source code of a function, that's rare, and it's also painful.
If you've reached that point, chances are you're already developing your own R packages.
Oh, I never made a package, and I've gone deep into some, mostly statistics, because there's a certain point where you're like, okay, how are you making a p-value out of this? Like, how? Seriously, just how?
AD says, I've never used R Markdown. Would you be able to show us the script in the RMD file? So maybe if you have a non-sensitive R Markdown file to.
Well, the notes are in R Markdown.
Awesome.
So yeah, R Markdown is all the beauty of LaTeX without having to deal with LaTeX. So when you start a new R Markdown, it doesn't have all of this, but it has some of this pre in there for you, where you can, in between these dashes, you set things that go at the top of the document, the headers. Here I have an automatic statement that updates the date for me whenever I knit it. And then a good example of, so how it works is you use hashtags to give headers. So like this is, the largest header is 1 hashtag, 2 get smaller, 3 get smaller. And then you have what are called code chunks. So this is an R code chunk where, the ticks and then the curly brackets ending in ticks. It's a little grayed out here. So this is all exactly where the R script. So when I made the R script, I copied my entire R Markdown, and then I deleted all my notes that weren't part of these blocks. And the really amazing thing, and the thing that whenever anyone wants to get in a Python argument with me, basically, is I point out that I do run Python. I run it in RStudio in a Python code chunk. So that's one of also the great things. If you're doing a workflow that uses multiple coding languages, if they happen to be supported, I can run R, obviously in R, but it also runs some others for me, including Python. And you type this code just like a script, only now when it knits, it makes a pretty document somewhere. There we go. So it automatically makes a pretty document and formats your code chunks, and then shows you what the output would be in the R console if you were running it. Yeah, thanks. Yeah, that's the link. And now this one's going to update because now it has a new date, which is fine. I will say that one of the most helpful things I found for R Markdown is there's inside of help, there are cheat sheets, and the R Markdown cheat sheet and R Markdown reference are very helpful to get started. And I have them printed at my desk at work for when I forget how to insert an image that's like a PNG versus a PDF, and when I forget those little syntax things. And there's also, tidyverse in here, dplyr, ggplet.
We have another question from H. So can you talk briefly about tidyr versus dplyr?
Yeah, so I guess we saw in the thing, oh, too far. So these are the list of packages that the tidyverse loads, including dplyr and tidyr. And they contain different functions that do different things. dplyr contains the things we were doing with like mutate and filter, and you can also select columns. So often dplyr is how to work within a data frame, like on a column, on a row. And then tidyr, the big ones that one has is if you want to transform a data frame, like rows to columns and columns to rows. So it's one of those interesting things that all of the functions in tidyverse play really well together, and they happen to be separated, but they all play well together. So it's like it's one package. So say if you're questioning whether to load, just dplyr and work with it, or just load the whole tidyverse, loading the whole tidyverse takes very little time. So might as well, because you might accidentally be using a tidyr function that is just the same in dplyr, but slightly different name.
Awesome. We'll do probably like the last call of questions if anybody has any, and if not, then definitely feel free to give your thanks to Kim. Kim, where can people find you online or around or?
Yeah, so the notes have my email. Feel free to, and I should have added. I'll add my Twitter hashtag too. It's K and then Dill-McFarland, my last name. I do tweet about R a lot. I also have Instagram, but it's only photos of my cat, so don't expect any science there. It's just literally just me trying to make my kitten famous. But same hashtag K Dill-McFarland for everything. And I'll add Twitter to that.
I'll definitely follow your cat.
Make Claire famous.
Yeah, thank you so much for this wonderful workshop.
Thanks everyone for attending today. Just a quick reminder as well, I'm going to paste a Google form link in the chat, and it helps us garner and gauge some interest for having like an open office hour where you'll be able to ask all of these questions and kind of get a chance to meet the other like ladies Vancouver members, just because we know that it's a little bit like quiet when it's all on like kind of one side. Yeah. And also Kristen says, thanks, Kim. I like your Memorial Union background.
Go Badgers. Can't tell where I went to school. This is my proof. Guys, Wisconsin's not always snowy. Sometimes it's nice. Anyway.